alkenes is what? Don't think about it. It's nickel. What do I call it? Nickel. Or platinum. Or palladium. And then they can still ask you, that is the catalyst that speed up the rate of this. Another question, they are jamb. So that means the catalyst that speed up the rate of what? Reaction for this and this to react with one another in order to make or is unsaturated hydrocarbon to become a saturated hydrocarbon, making double bond to become a single bond. It happened as a result of nickel as the catalyst, and it also happened as a result of platinum, palladium. So these are the three catalysts that jamb might ask. What is the catalyst involved during the hydrogenation of alkenes? Hydrogenation of alkene. The word hydrogenation, addition of hydrogen. If it is halogenation, addition of halogen family. Like bromination, addition of bromine. Chlorination, addition of chlorine. Iodination, addition of iodine. Astatination, addition of astatine. But we are dealing with hydrogenation. So when we add it, and the essence of this additional reaction is that it makes an unsaturated hydrocarbon to become a what? Saturated hydrocarbon. ENE to become ANE as a result of nickel. Or if you don't see nickel there, we can see platinum or palladium. Then another second question that jamb might still ask, at what temperature? At what temperature? Know that you don't think of anything. It is at 140 degrees Celsius. 140 degrees Celsius. 140 degrees Celsius. That is it. It burns at what? 140 what? Degrees Celsius. These are the things they can actually what? Ask you there. Hope I'm communicating. The next thing is that this process, we call it additional reaction. But the name implies is hydrogenation. We are adding hydrogen to ethene. So your assignment on that one is what of C3H6? This is what now? This is propane. Propane. So when you add hydrogen to it, this is additional reaction. Addition means adding something. But under what? Hydrogenation, it is hydrogen that we're adding to it. What is the product that you get there? So that is your question there. And what catalyst? Nickel. I've explained that. So please, these are the key words. The catalyst, the temperature, the product that will be formed. If jamb might still ask you the last question here, that the addition of hydrogen gas to an alkenes give what product? It results to A, saturated hydrocarbon, B, unsaturated hydrocarbon, C, none, D, all of the above. It is what? Saturated hydrocarbon. How together? So these and this. So number 2 on this, let me quickly do another one here. I will still use ENE, but I will use hydrogen. Let me do that of bromination. When we say bromination, I mean the addition of bromine to this. Bromine. Now the next thing is that we are still under additional reaction, under ENE. And then the additional reaction, now this will not be hydrogenation the way we did earlier. This will be bromination. The addition of bromine. The addition of what? Of bromine. The addition of bromine to ethene. The addition of bromine to what? Ethene. Don't mind me that I'm using ethene. It's a common example. That's why I'm using it. You too, you can use propene. You can use butene, pentene. Then add bromine to it. So know that when you are adding bromine, or you are adding chlorine gas, or you are adding what? Iodine gas, or you are adding what? Fluorine gas, you are adding all these things. They fall on family of what? Halogen group. Are we together? They fall on what? Family of what? An halogen group. Hope I'm communicating. In nutshell, in what sense is that? So all these things, what end is? Bromine, INE. Chlorine, INE. Iodine, INE. Astatine, INE. They are all halogen group. So the addition of halogen group to an alkenes family is what we call what? Halogenation. So when we now pick one of that is their father name. When we pick one of them, like bromine, we call it bromination. When we pick chlorine and we add it to ENE, we call it chlorination. When we pick iodine, we add it to ENE, we call it iodination. When we pick fluorine, we add it to this, we call it what? fluorination. Hope I'm communicating. Then what is the essence of we adding this to this one? It is to make the addition of this one to this is to make it from unsaturated hydrocarbon double bond to a what? To a saturated hydrocarbon ANE single bond. Hope I'm communicating. Now it's very easy. All you need to do now, you do. Let me erase this. So please, your assignment is you do for this one. You can use C3ACs. Do for this one. When you add it together, what is it going to give you? So we are still under halogenation. So when we define halogenation is the addition of what? Group 7 element. Group 7 element to ENE. Hope I'm communicating. So that is that under that. Let's quickly do this one now. Let me add bromine to this one, to ENE. There, for more clarification, these are molecular formula. Let me use the structural formula to do that. The molecular formula of this is C2H4Br2. This is the molecular formula. Now let's do it structurally. Structurally mean this is the product that we are going to get. Structurally mean I should draw this shape. This is 18 plus this is bromine gas. Bromine cannot start alone. You put 2 here because it is diatomic in nature. So now note that the rule said this bromine gas, when is attacking this like this, it will break one bond here. When it break one bond here, that means 2 bromine break one bond here. One bromine can never break one bond. One chlorine can never. Chlorine, 2 chlorine gas, iodine gas. So when it break one bond here, it make it, we will left with how many bond? Single bond. It make it to be a what? Saturated compound. From what? Unsaturated what? Compound. Are we together? The question that JAMB we now ask here is that the addition of bromine gas or the addition of hydrogen gas, iodine gas, or the addition of chlorine gas to an unsaturated hydrocarbon, that is ENE, lead to dash compound. A, saturated hydrocarbon. B, unsaturated hydrocarbon. C, hydrocarbon. The correct option to pick there is that was saturated hydrocarbon. Hope you are getting what I'm saying. So now that is the question that they can ask you there. And they can ask you what type of reaction is that. A, when you are adding this one, the addition of bromine gas, the addition of iodine gas, the addition of chlorine gas, the addition of fluorine gas to ENE is what type of reaction? That is another JAMB question. Is what type of reaction? A, hydrogenation reaction. B, halogenation reaction. C, saponification reaction. E, esterification reaction. What should come to your mind? Halogenation reaction. These are the few questions. They just want to know if you actually comprehend the SSCE program that you have done so far. The exam is just to test your what? Your performance, your understanding regarding the SSCE what? The SSCE approach. Are we together? Now let's quickly do that. I told you that 2Br is what will break one bond here. When it break one bond here, it's very simple. 2 carbon. We are left with single bond. That bond that it break, it will stand here. Now, what are we having here before? Hydrogen. You can have it 1, 2. You can put hydrogen here. You can put what? Hydrogen here. Then put 1 bromine here. Then what are we having here? 2 hydrogen. You can make it hydrogen here. Hydrogen here. The other bromine, we have used 1 bromine. The other bromine, you put it here. So now, this is what now? ENE. From ENE to what? ANE. As a result of what do we know that? What makes us to know that this is ANE, Alkene, is as a result of single bond. What makes us to know that this is ENE? It as a result of double bond. So the addition of halogen family like bromine to this one make it to become a saturated hydrocarbon. Now, meaning the additional reaction make an unsaturated organic compound to become a what? A saturated organic compound. Are we together? As a result of having single bond. Now, let's try to name this. Please check on our class on the nomenclature of Alkene. This is our Alkene structure. Let's try to name it. How many carbon are we having? 1, 2. Is there any carbon at top? No. Any carbon like this? No. Any carbon here? No. So we have 1, 2. So that is 2, which is ethane, right? ethane. How do we know that it is ethane? It's as a result of single bond. And carbon 2. Carbon on number 2, it is ethane. Single bond. That's why we put ANE. Now what follow? What are the substituents? We have only 2 substituents here. Branches, which is bromine and what? Bromine. Now let's count. This one, we can count from any side. Because bromine is here. So this bromine, that is only substituent. Fall on carbon number 1. If we start counting like this, also fall on carbon number 1. So let's count from here. So you can start from any other side. This will be 1, bromine fall on this carbon number 1, and it is closer to this carbon. And if you start from here, bromine is also closer to this at 1. It will now be 1, comma. It's because we are having 2 bromine. 1, the first bromine is on carbon number 1. So let's just say 1, 2. The second bromine is on carbon number 2. 1, 2. Are we together? What follows? Dibromo. Bromo. Are we together? 1, 2 dibromo what? Ethane. 1, 2 dibromo ethane. That is that under that. So we call this type of reaction. We call it what? We call it what? A substitutional what? A additional reaction. Hope you are with me. So that is that under that. Now do that of chlorine. Do that of iodine. And if actually, so do that of bromine. Do that of iodine. And do that of fluorine. The next thing that I will be introducing, these are the few questions that is that what of, we are still under additional reaction. What of if they say ENE is reacting with jamb? We ask you the reaction between ENE the reaction between ENE with hydrogen halide. Hydrogen what? Halide result into what? Or they can bring one structure, or they can bring one molecular formula in the reactant side, and they will bring one structural form, one product formula, or one molecular formula in the product side. They will now ask you, it is classified under what? EN is reacting with halogen halide to form what? Then what is the catalyst? The reaction between when ENE, which is when I'm having C, this is hydrogen, 18, this is 18, and I'm having hydrogen halide. Hydrogen halide means I'm having hydrogen with halogen group. So when hydrogen is reacting with halogen group, when hydrogen is reacting with what? Halogen group, we call it hydrogen halide. So when ENE react with hydrogen halide, jamb will now ask you, what is the catalyst involved? When ENE react with what? Hydrogen, and this X, it is a symbol for halogen group. It is a what? Symbol for what? Halogen group, like bromine, chlorine. So when a symbol of an halogen group react with hydrogen, we call it hydrogen what? Halide. Are we together? Hydrogen halide. One, they will jamb will now ask you, they will bring this type of structure. They will ask you, what is the catalyst involved for this reaction to occur? A, aluminium 3 chloride. B, aluminium 4 chloride. C, aluminium 5 chloride. The catalyst involved, even for those preparing for SSCE certificate, the catalyst involved when you see this type of structure, and WAEC asks you or jamb asks you that for this reaction to occur, to form the product side, what is the catalyst that you are going to, that speed up the rate of how this? It is what? Aluminium what? Aluminium 3 chloride. Aluminium what? 3 what? 3 chloride. This is the catalyst involved doing that. And what is it going to? So please cram that. The catalyst involved is what? Aluminium 3 chloride. Now, as a result of what? Now, meaning this hydrogen will break this bond. This HCl, HX will break what? Will break this bond. When HS break this bond, what are we? The same thing that we do here. We have hydrogen. This is hydrogen. The 2 hydrogen here. The single bond will remain. What? We have 1 hydrogen, you will put it here. Then what? We have these 2 hydrogen. We have 1 and we have 2. Then what left? X. You put the X here. Hope I'm communicating. So Now let me use this now. This has been come from what?